previous discussion about trusses, we looked at a truss like let's say like this one, and we attacked it using a thing called method of pens. So we basically did the global equilibrium, where we solve for all the forces at the reactions. So in this case, the reactions that would be at A and the reactions that would be at K. And then we basically step through it doing a free body diagram for each pen, right? So pen A, then we'd maybe go to pen B, then we go to pen C, then we go to pen D. And so in doing method of pens, we were able to get the forces in every single one of the bodies or members that were in this thing. However, it had the downside that if we have a very general truss like this one, we'd have to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 free body diagrams. That's a lot of free body diagrams. So what happens, or how do we work with this if we only really want three, let's say three things? So let's say we've been asked to find the forces in that member, this member, and this member. So DF, EF, and EG. Well, what do we do? So I guess you could of course do the method of pens, do the global equilibrium, start at A, and then walk through there, doing 1, 2, 3, 4, and then 5 free body diagrams to solve for all of the forces in this truss. Not to forget the global equilibrium to get A and K. Or we could do this alternative method, which is called the method of sections. So in this method, what we're going to do is we're going to think about cutting open the truss and just analyzing that directly. So I'm going to draw this line right here. And this line we consider it to be a cut. And so what that lets me do is I am going to be able to go ahead and draw, oops, it's a bad idea, let's not do that. Draw the free body diagram of just the piece that we cut loose. Right, so this is A here, B, C, and D, and then we cut through DF. And anytime, just like in the regular free body diagrams that we've done in chapter 3, anytime you cut through something, you have to replace it with a force that represents the action of that body. And so in this case, right, we've got a force in DF, a force in EG, and then a force, of course, in EF. And so let me delete that one because I didn't stay consistent here, so there it is. We have the reactions at A due to, let's say, a force here, P, and then a force here, Q. Notice when we draw this free body diagram, there's that external force, so we have to include it. So that's got to still be there. And here we go. And so what we do now is we then just solve this using some forces equals 0, and then some moments equals 0. So again, right, these are inherently 2D structures, like all trusses that we've talked about. So we only get 3 equations. So we can only possibly solve for 3 unknowns here. So be aware of that when we go. But the method of sections is simply find the place, make a cut, keep one side, either this side or this side, draw the free body diagram of the remaining piece, make sure you include all the forces, and then solve for it using method, just standard equilibrium, right? This just becomes a simple rigid body problem like we had before. Of course, we typically assume that we know dimensions. All right. A lot of times you're going to have to solve for angles, specifically that angle theta. We don't know it, but typically we would be given this dimension and then information about these dimensions. And then from those two things, right, we can easily sort of figure out what the angles are. So it really boils down to a simple moment sum and force sum, and then we, of course, have to do some geometry to solve that. And that's really all there is to method of sections. The idea, of course, is the sort of underlying idea here being that we are making a cut through a body and exposing these forces, DF, EF, and EG, that are internal to member DF, EF, and EG. This really isn't any different than method of pins. What we were doing in method of pins was cutting through everything and just isolating a pin. And then we were, of course, replacing AB and AC with its internal forces. So it's exactly like method of pins from the basic thought that we cut free something and then analyze it. But in this case, instead of it just being a point equilibrium, now we have a full rigid body, and we can bring in moments and add an extra equation to get us our 3 equations and 3 unknowns.